All right, this is 2-6 piecewise function, so follow along with me on page 9 of your guided notes packets. So this concept of a piecewise defined function, it's literally a graph that's in pieces. Okay, so it means that depending on what the value of x is, we're going to plug it into a different equation according to like what criteria the x meets. Okay, so these are still functions, meaning they should still pass the vertical line test, but it's going to be broken up into pieces. The easiest way to work with these types of functions is just to jump right in. So this first example, we would read this as f of x equals, and then there's a couple different things that f of x might equal depending on what x is. So this bracket represents all the possible equations that we'll be working with. Okay, so this basically means that f of x equals 2x if x is in between -5 and 2. But then if x is in between 2 and 6, then f of x is going to become 5. Okay, so a process that's going to work for all of your piecewise defined functions is to create tables. Okay, so my recommendation, I'll change colors for you here. So we'll make the top one be purple. So x and then 2x. Our possible values for x here, I'm going to have my two endpoints. So -5, and then also x could be up to 2. And then I'm going to double each of those. Okay, so I'd recommend giving yourself like some points here in the middle. So maybe like -3, 0, 1, and then double each of those x values to get your y values. And what we're doing here is we're generating ordered pairs. So on our graph over at when x equals -5, we're going to have a point down here at 10. And you need to be very careful to think, is this going to be an open circle or a closed circle? It's a closed circle if we have a greater than or equal to, and it's an open circle if we have a less than or greater than. So it follows the same rules as inequalities. Okay, so basically what's going to happen is instead of having lines, we're just going to have segments. Okay, so 6, we're going to have some segments, and we can see that this slope is going to be up to over 1. So if we wanted, we could just generate our extra points that way. Keep in mind that as soon as we reach x equals 2, we need to draw an open circle, and we're going to stop. Okay, and then our line segment is going to join those 2 points. So if we create a line segment that connects all those points, that's what we're working with. For our other part, as soon as x is equal to 2, in between 2 and 6, we're going to follow the other piece of this function. So f of x equals 5, that's just going to be a horizontal line. So we don't have to make a table if we don't want to, because we know that as soon as x equals 2, we're going to go up here to 5. Okay, and then we're going to have points that go like this all the way up until x equals 6. So this is where x equals 6, that's where our segment is going to stop. So I'm going to create a segment right there, and that is our piecewise function. So we have closed circles on both ends because we have less than or equal to symbols. And that's what our graph looks like. So they can get a little bit more complicated, as you can see from this example. So I'll make this top one green, x and x plus 3. So for my endpoints, x could equal -8 all the way up to 1. And then give yourself some points in between, so maybe -7, -5, -3, -1, and then generate those y values. So -8 plus 3 is -5. -7 plus 3 is -4. As you keep going, you will see ordered pairs. Okay, and keep in mind that this first ordered pair is going to have a closed circle because it's a less than or equal to symbol, and this bottom pair is going to have an open circle because it's a less than symbol. So we can go over and graph these. If we graph -8, -5, that point is going to be way over here. It's going to be a closed circle. And then we can move up and over if we're using our slope. That would be helpful. Up 1 over 1, up 1 over 1. This is going to carry on all the way over until the point 1, 4. Okay, so we're going to have a nice little segment right there. Be very careful when you're connecting these points. They'll look like that. And then for your other piece, we'll have x, and then we'll have 10 minus 2x. And our x values could go all the way up from 1 to 7. So I'll go every other odd number, 1, 3, 5, 7. And then fill in my y values. Okay. And then graph my points. So over 1, up 8. And then I can use my slope if I want. Down 2 over 1, down 2 over 1. Keep in mind, do we have closed or open circles? Because these are both less than or equal to symbols, we're going to have 2 closed circles. Let's see where are we ending up. And then at x equals 7, that's going to be where we stop our segment. Okay. So this is our piecewise function. So keep in mind, because these are functions, they still need to pass the vertical line test. And so even though we have this gap right here, it's not a continuous function because we can't draw from one point all the way to the other without having to pick up our pencil. But it is a function because if we look at the graph, think about the vertical line test from left to right, we don't have any y values, or excuse me, we don't have any x values that are going to 2 values of y. Even though we have this gap right here because we have an open circle and a closed circle, there is still only one point that is defined at that value of x. Okay. I'm going to end the video here. That is how you graph. And then in the next couple, we will practice creating equations and evaluating piecewise functions.